Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 10th lesson on a given Form 3 mathematics topic called sequences and series. So we are looking at our 5th example on geometric progression, which is a past Kcse equation tested in 206, paper 2, question number 22. So it reads that the product of the first 3 terms of a geometric progression is 64. If the first term is a and the common ratio is r, part A of the question, we are required to express r in terms of a. So because we are told the first 3 terms of a geometric progression, and we know that the first term of either an AP or a GP is always given by a, then because we are being told that the first 3 terms of a geometric progression, we know that the nth term of any given geometric progression is given by ar to the power of n minus 1. Therefore, if we want to find the first 3 terms of this particular GP, we already have the first term. Therefore, we find the second term, of course, which will be given by ar to the power of, now our n will be 2, then of course minus 1, which is going to give us ar to the power of 1, that is 2 minus 1, you get 1, which will simplify to ar. We'll also find the third term of this particular GP, which is equal to ar to the power of 3 minus 1, which of course is going to simplify to ar to the power of 3 minus 1, you're going to get a power of 2. So we are told that the product of the first 3 terms. So when you take the first term, then of course you multiply with the second term, then you multiply with the third term. This particular product should give us 64. That's the product of the first 3 terms. Remember, the word product in mathematics simply means multiplication. Therefore, if I take the first term, of course, which is denoted by small a, then I multiply with the second term, which is denoted by ar. Then I multiply with the third term, which is denoted by ar squared. This particular product is supposed to give me a positive 64. Then this equation can still be simplified because I can see it has some like terms. Therefore, we can group the like terms together such that we are going to get the following. So I'll group the a's together. So this is a multiplied by a multiplied by a. So we have 3 a's, 1, 2, 3. Then of course we have r. Then of course we also have an r squared. Then the whole thing is equivalent to positive 64. So a is the same as just a power 1, a power 1, a power 1. Then from the laws of indices, whenever you have a power m, then you multiply with a power n. This is the same as saying a power m plus n. That if the bases are the same, you are allowed to add the powers. Similarly, this is the same as saying a to the power of 1 plus 1 plus 1. Of course, we have 3 a's. Then multiplied by, we have r. This is the same as just saying r power 1. Therefore, because we have the base of r and r, we'll just add 1 plus 2, which are the powers. So this one should give us positive 64. Now, when we simplify the numbers on the power, we are going to end up with a to the power of 1 plus 1 plus 1, you'll get 3. Then, of course, r to the power of 1 plus 2, you'll get 3, being equal to 64. Now, this one can still be simplified. Remember, we can express 64 as, if we check the factors of 64, we can start by 2. So this is 32. By 2, this is 16. Then, of course, by 2, this is positive 8. By 2, this is 4. By 2, this is 2. Then by 2, this is 1. So this one simply means that 64 can be expressed as 2 to the power of 1, 2, 3, 4, 5, 6. So this is 2 power 6. So we can talk of, this one can be rewritten as ar. Then I just factor out the cube being equal to 2 to the power of 6. Then of course, if you want to remain with ar, you'll multiply by a third on each of the power, or you simply say you multiply by, you take cube roots on both sides. So if you take cube root on this side, you also take cube root on this other side. Cube root is the same as saying multiplied power a third. So this is the same as saying ar then the whole thing to the power of 3, then multiplied by a third, which is representing the cube root, which should be equal to 2 to the power of 6 multiplied by a third. Of course, the 3 and 3 will cancel out, so we'll remain with AR being equivalent to 3 here 1, 3 here 2. So we'll remain with 2 power 2, which of course is going to give us a positive 4. Remember, so we are ending up with A. We are ending up with A being, that is AR being equal to a positive 4. Remember, the same step can also be easily handled this way. So from this particular point, we can also handle it this way, just using our calculator. So we can still handle it this way. So this is AR, then of course this is cubed, then this one is equivalent to 64. So you can just decide to find a cube root on both sides of this equation, so that we can eliminate the power 3. So you find the cube root here, you also find a cube root on this other side. So the cube root and the cube I will just cancel out, so you remain with AR being equal to, if you want to find the cube root of 64, these are the procedures that you press on your calculator. You can press 3, then you press the shift symbol, then after that you press this particular symbol on your calculator, then you press 64, then you press equal sign. The calculator is going to give you your answer as positive 4. So you press 3, shift, then this symbol, then 64, then equal sign. You are going to get your answer as 4. So we are still going to end up with AR being equal to positive 4. So this one is equals to positive 4. But remember, in part A, they wanted us to express R in terms of A. So in short, they just want us to make R a subject of the formula. So to achieve that, I'll divide through by A. I also divide through by A, so that A and A will cancel out. Therefore, R is equivalent to 4 over A. So our R, so this is the answer for part A, R is equals to 4 over A. So we have actually expressed R in terms of A. Then we'll move to part B of our question. Let me make a line here that can separate our working. So in part B of the question, we are being told that, so let's check part B of the question. So we are told, given that the sum of the 3 terms is 14. Remember, the 3 terms, they are referring to the first, the second, and the third term. Remember, sum simply means addition. Therefore, in part B, Roman 1, we are told that the sum of the 3 terms is 14. Therefore, if I add the first term, remember the first term was A, then I add it to the second term was AR, then I add it to the third term was AR squared, that this particular sum is supposed to give me a positive 14. So in Roman 1, find the values of A and R, hence write down the 2 possible sequences, each up to the 4th term. So we first of all need to find the values of A and R. So to achieve this, I'm simply going to substitute. I can label this as my first equation. So let this be my equation 1. Then I'll let this one to be, I want to substitute. So I'll simply say substituting equation 1 in, substituting the first equation in A plus AR, then of course plus AR squared is equals to positive 14. I'm going to get the following. So that means that where I have R, I'll substitute with 4 over A. So this would remain to be A, then plus A, then of course I'm having R here. So R is 4 over A, so this is 4 divided by A, then plus A into R squared. R is 4 over A, then of course it is R squared. Then this one is equals to positive 14. So this will give me A, then of course plus this A and this A will cancel out. So we remain with positive 4, then plus A. Then squared simply means that you are going to square everything. So 4 squared will give us positive 16. Then A squared will just give us A squared. Then this one is equals to a positive 14. Of course, there are terms which can cancel here. So A here 1, A into A squared, A times. So we are going to remain with A, then of course plus 4, then plus will remain with 16 over a being equal to positive 14. So I can eliminate the fraction by multiplying through with the LCM. Of course, our LCM is just a. So I'll multiply everything by a. So this one times a times a times a times a. The reason why I'm doing that is because I want to do away with the fraction so that I can easily solve the remaining equation. So a times a, I'll simply get a squared. Then of course plus 4 times a, I'll get 4a. Then plus here the a and a will cancel out, so I'll remain with positive 16 being equal to 14a. Then let me complete my working from this particular area here. So let me clean it. So we are going to end up with the following. So this is what we are going to end up with. So we'll end up with, we are having a squared. So I'm still having a squared. So we have a squared. Then of course here I'll take 14a to this other side. So 4a minus 14a, I'll get a negative. I'll get a negative 10a. Then of course plus 16 being equal to, on the right hand side I'll remain with 0. So of course this is a quadratic equation in the form of ax squared, then of course plus bx, then plus c is equals to 0. So clearly the value of a will be the coefficient of a squared, of course, which will be 1. The value of b will be negative 10. Then our value of c will be positive 16. So that means our value of a will be given by the quadratic formula, which states that negative b plus or minus square root of b squared, then minus 4ac, then the whole thing divided by 2a. So we need to substitute that. Let me clean this particular area so that I can use it to perform my working. So if I substitute, I'm going to end up with, so this one is equals to, negative b will be negative, our b is negative 10, so negative 10, then plus or minus square root of b squared, our b is negative 10, so this b squared will be negative 10 squared, minus 4 multiplied by a, our a is 1, then c is positive 16, then the whole thing is divided by 2a. So this is going to give us negative will give us positive 10 plus or minus. This will be the root of negative 10 squared will give us positive 100 minus 4 times 16 will get positive 64, then divided by 2 multiplied by a. Remember our value of a is actually 1. So here I'm supposed to substitute with 1 instead of a, because our value of a is actually 1, so times 1. So this one will just remain to be divided by 2. So when we simplify, this will actually give us a positive 10 plus or minus 100 minus 64 will get root 36, then divided by 2. So this is going to give us the following. Let me separate my working with a straight line here. I can as well clean this particular side so that I can complete my working. So this is going to give us the following. So we'll end up with the value of a being equal to positive 10 plus or minus. The root of 36, of course, is positive 6, then divided by 2. So this one means either a is equals to 10 plus 6 divided by 2, which will give us 16 divided by 2, which is equals to 8, or the a can also be given by, our value of a can also be given by the following. So we substitute when the sign in between 10 and 6 is negative. So this will be 10 minus 6 divided by 2, which will give us 10 minus 6 will get positive 4 over 2, which is going to give us a positive 2. So these are the possible values of a. We also find the possible values of r. So we are going to say that when a is equals to, we'll start with a being equal to 8. When a is equals to 8, r is equals to, remember from equation 1, r was given by 4 over a. So this will be 4 divided by our a is 8. So this one is going to remain to be a half. Therefore, when a is 8, r is equals to a half. So we are told to find the values of a and r, hence write down two possible sequences each up to the fourth term. So let's write the first possible sequence. So the first sequence will be, our first possible sequence will be given by the following. So we need to find the first term, the second term, the third term, and also the fourth term of that particular first sequence. So for us to get the first sequence, I'm simply going to find all the possible terms of that particular sequence up to the fourth term. So the first term, of course, is a. So the first term of this sequence will be a. Of course, we are using when a is equivalent to 8. Then the second term will be given by ar to the power of 2 minus 1, which will be equal to, the first term is a. Then the common ratio here, the common ratio is a half. So this will be a half. Then to the power of 2 minus 1, I'll just get 1. So this is going to give me 8. Then, of course, multiplied by a half, which will give us 2 into 8. That is positive 4. Then the third term of this particular sequence will be ar to the power of 3 minus 1. So our a is 8. Then a into r, our common ratio is a half. Then to the power of 3 minus 1. So this will give us 8 into, so this will be a half to the power of 3 minus 1 will get 2. So this one means 8 multiplied by 1 squared will get 1. 2 squared will get 4. So 8 over 4, we are going to get a positive 2. Then the fourth term will be given by, remember the fourth term will be given by a. The first term was 8, then into, the common ratio was a half, then to the power of 4 minus 1. So this will give us 8, then into bracket a half to the power of 3. So this one means 8, then into 1 cubed is just 1. 2 cubed will give us 8. So the 8 and 8 will cancel out, therefore we'll get 1. So it means our first sequence, the first sequence will be given by, the first term was 8. The first term is 8. Then the second term, our second term is positive 4. The third term, our third term, we got it as 2. Then, of course, the fourth term is 1. We were told up to the fourth term. Therefore, this is our first possible sequence. Then we'll move to the second possible sequence. So for us to get the second possible sequence, we are also going to find the first term of that particular sequence and, of course, the common ratio. Now, for the second sequence, we'll use the first term being 2. So for the second sequence, our first term is positive 2. Then we also need to find the common ratio. The common ratio will be, let me see. Yeah, our first term is 2. So the common ratio was given by, that is the equation in part A, which was 4 over A. So this is 4 over A, which is equals to 4 divided by our A, of course, is 2, which is equal to 4 over 2 will give us positive 2. So this is the common ratio. So the first term of this second sequence is 2. So our second term is given by ar to the power of 2 minus 1. Therefore, this is what we are going to end up with. Let me clean this particular area so that we can use it for to complete our working. So our second term will be of now the second sequence. So the second term will be equivalent to, our first term of the second sequence is 2. Then into the common ratio, we've also found it to be 2. Then to the power of 2 minus 1. So this will be 2 into 2 to the power of 1, which is equals to 2 times 2, which will give us positive 4. Then we find the third term. The third term will be, we'll have a, which of course is 2 into the common ratio is also 2, then to the power of 3 minus 1. So this will give us 2, then into bracket 2 to the power of 2, which will give us 2. 2 power 2, we are going to get positive 4. Then, of course, 2 times 4, we are going to get positive 8. Then the fourth term will be given by, the first term of this, the second sequence is 2. into the common ratio is 2, then into 4 minus 1. So this is going to give us the following. So this is what we are going to get. So we are going to end up with, so we'll have the fourth term being equal to 2 multiplied by 2 to the power of 3, which is just 2 multiplied by 2 power 3, we'll get positive 8. 2 by 8, we get positive 16. Therefore, the second sequence will be given by, the first term is A, which of course is 2. The second term, we got it as positive 4. Then the third term, our third term is positive 8. Then of course, the last term or the fourth term is positive 16. So this is our second possible sequence, 2, 4, 8, and 16. 2, 4, 8, and 16. So we're required to find the values of N and R, hence write down 2 possible sequences up to the fourth term. So we've answered that. Then we move to B Roman 2 of the question. So in B Roman 2, so this is B Roman 2, whereby we are required to find the product of the 50th terms of the two sequences. So we'll find the 50th term of the first sequence. So the 50th term of the first sequence will be given by, we know that the nth term of any given GP, that is geometric progression, find the product of the 50th, that is the 50th term. So the nth term of any given GP is given by, we know that the nth term is AR to the power of n minus 1. Therefore, 50th term should be AR to the power of 50 minus 1. Now, let's use the first sequence. So for the first sequence, the 50th term will be given by the following. The first term of the first sequence was positive 8. So our A is 8. Then into the common ratio of the first sequence. Our common ratio was actually, if we find the common ratio here, we'll just take 4 over 8, which was actually a half. The common ratio was a half. Then to the power of 50 minus 1. 50 minus 1. So this is going to give us 8. Then of course into bracket a half to the power of 50 minus 1. We'll just get positive 49. Then we'll also find the 50th term of our second sequence. So for us to find the 50th term so that we can get the product, we are going to have the following. So the 50th term now of the second sequence will be given by, of course, AR to the power of 50 minus 1, which will be given by, the first term of the second sequence was actually positive 2. So this will be 2 into, the common ratio was also 2, because R will be given by 4 over 2, which is equal to 2. The common ratio was 2 to the power of 50 minus 1. So this will give us 2 into 2 to the power of 49. Therefore, the product, remember product means multiplication. So if we take the first 50th term, if we take the 50th term of the first sequence, so the product means we'll take the 50th term of the first sequence, then we multiply with the 50th term of the second sequence. So this particular product should give us the following. So the 50th term of our first sequence was actually this one here. It was 8. So this was 8 multiplied by into a half to the power of 49. Then we are supposed to multiply with the 50th term of the second sequence is it is here. So this is 2 multiplied by 2 to the power of 49. So this particular product should give us the product of the 50th terms of the two sequences. So we can collect the like terms. So I can combine 8 and 2. Then of course I combine a half to the power of 49, a half power 49. Then I also combine it with 2 to the power of 49. So of course 8 multiplied by 2, I'm going to get positive 16. Then multiplied with I'm having a half to the power of 49. Then I'm multiplying with 2 also to the power of 49. Now this second part, I can use a certain law of indices that we learned in Form 2. Remember, in Form 2 we learned about 7 laws of indices. It is actually a chapter that we covered in this particular channel, so you can just review from indices Form 2. It is a topic that I covered in this particular channel. So in that topic, there is a rule of indices whereby we said that if you have an A, if you have A to the power of M, then you are multiplying with a different base, for example, B to the same power. This one is the same as saying A multiplied by B, then the power just goes outside this way. So applying this rule on this part, it means that if I take a half, then to the power of 49, then I multiply with a 2 to the power of 49, because the powers are the same. This is the same as saying a half multiplied by 2, then the whole thing to the power of 49. So of course 2 and 2 will cancel out, so it remain with 1 power 49. But remember, 1 to any power, the answer will always be equal to 1. So 1 power 49 will just give you 1. You can actually verify this using your calculator. 1 to the power of 49 is 1. 1 to the power of a million will be 1. 1 to the power of 0 is 1. 1 to the power of a billion, you are still going to get a positive 1. Therefore, it means that now our equation is going to disintegrate into, so this equation will now remain to be 16, then of course multiplied by this part has given us positive 1. So 16 multiplied by 1. Therefore, it means that our final answer is going to be 16. Therefore, the product of the 50th terms of the two sequences is actually positive 16. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kcse Tuition Academy. Thank you very much.